Today in class we did four examples. One of them was simple and we did one like it yesterday, so I'm going to do the three examples that were a little more challenging. The first one is an equation with variables on both sides of the equal sign. 2x minus 1 equals 5 minus 4x. Now, as I said in class, there's lots of different ways we can start this. We could start this problem 4 different ways. And it's just like if I want to go out to the bus ramp for my afternoon bus duty in the million-degree heat, I can walk down the stairs by the cafeteria and out to the bus ramp. I can walk down the back stairs by the language arts classrooms and out to the bus ramp. I can go out the front door and walk around. I could jump out Miss Canopy's window. I've got lots of options, but they're all going to land me in the same place, the bus ramp. The same thing goes when we solve equations. There's lots of different ways I can start this equation, start to solve it, but they're all going to get me to the same answer. The way that I'm doing it is the way that I was taught, but if you choose to start in a different way, it doesn't matter because you're going to get to the same answer anyway. So I was taught to move the x's to the left side and the variables to the, and the constants to the right, so that's what I'm going to do. So because I have negative 4x here, I'm going to add 4x to both sides. So I forgot my wall here. Okay. And then these zero out. That gives me 6x minus 1 equals 5. Now, I've got my x variables, or my variables, on one side of the equal sign, but I've got to get rid of this negative 1 so that I have only x's on this side and only letters on the other. So to get rid of minus 1, I add 1. These zero out, and I have 6x equals 6. When I divide both sides by 6, I get x equals 1. Now, as we talked about in class, I like to get the right answer. I assume that you also like to get the right answer. There are 2 ways that we can check our work to make sure that we are doing the right thing. The first thing we can do is we can manually check by substituting. So I can take my original expression, 2x minus 1, and everywhere I see an x, I'm going to put my answer, which is 1. So 2 times 1 minus 1 equals 5 minus 4 times 1. If it's right, if I got the correct answer, I should get a true statement. So when I'm done, whatever's on the left should be equal to what's on the right. So 2 times 1 is 2. 2 minus 1 is 1. So that's the left side. Let's see if it's equal to the right. 4 times 1 is 4. 5 minus 4 is 1. Does 1 equal 1? Most certainly does. So that means that I solved correctly. The other way I can solve this problem involves using my calculator, which of course I cannot find. Ah, here it is. Okay. So what I can do with my calculator is I can take this equation, and I'm going to go into y equals, I'm going to clear all this out because I got all kinds of stuff in here, and I'm going to put whatever's on the left side of the equal sign, 2x minus 1. And remember, we're going to use the xton button here as our variable. And then on the right side, whatever's on the right side, I'm going to put in y2. 5 minus 4x. Okay? And then I'm going to look at my table. Now, I think that the answer is 1. So I'm going to scroll to 1. And if I'm right, I should have the same value for y1 and y2, just like I got over here. Also, you notice I have the same numbers as I had in y1 and y2. If you choose to check your work with a calculator, that's totally okay. But what I expect to see, I expect you to copy what you see in that table that leads you to believe you have the correct answer. So I want to see this row. X equals 1, y1 is 1, y2 is 1. Now, it just lucked out that in this case, y1 and y2 were the same thing as x. It doesn't usually happen that way. Occasionally it does. Okay? So that's a simple variables on both sides of the equation problem. Now, we're going to try something a little bit harder. This one's going to have a fraction in it. This one is 4/5 t minus 6 equals 2t plus 6. Okay? So in this case, I have this fraction here. And many of you may be saying to yourself, can I turn this into a decimal? Could I just write it as 0.8? You totally can write it as 0.8. But there are going to be situations where you can't do that. For example, if you have 1/3. 1/3 is a non-terminating decimal. It's 0.33333333, and we are not allowed to do that. In algebra, we need precise answers, and we're not going to get a precise answer when we're never going to be able to get a precise answer if we use a non-terminating decimal. So yes, I completely agree you could turn this into 0.8, but for demonstration purposes, we're going to not do that. Okay? What we're going to do seems a little weird, but it is absolutely correct, and there's nothing wrong with it. We're going to find the least common denominator. In this case, we only have one denominator, 5, so we're going to multiply every single term by 5. Okay, so that means I'm going to take 5 times 4/5 t plus 5 times -6, oops, I forgot my wall again, equals 5 times 2t plus 5 times 6. So again, all I've done is I've scaled up everything in this equation so that I can get rid of this denominator. If you want to, you can use your calculator to do the math on this, but we multiply by the top and divide by the bottom. 5 times 4 is 20. 20 divided by 5 is 4t. 5 times -6 is -30. 5 times 2 is 10t. 5 times 6 is +30. Now I have something that's a lot easier to work with, a lot prettier, a lot less crazy looking. Okay, so now I'm going to solve this one. Again, there's a lot of ways we can start this. This time I'll start differently. I'll add 30 to both sides. Okay, we're going to zero that out. We have 4t equals 10t plus 60. I'm going to subtract 10t from both sides. This zeroes out, and I get -6t equals 60. Divide both sides by -6, and I get t equals -10. Now again, I can check this by going back to my original expression and substituting in, or I can use my calculator. Now I'm going to show you the calculator because I want to be able to show you also how to use the fraction. So we're going to hit y equals, and again I'm going to clear out what I have in my calculator. Now if I want to put that 4/5 fraction, I can do 4 divided by 5, which is totally legit, or I can hit alpha y equals, and it brings up this little menu. And in this menu, it gives me n over d, which is numerator over denominator. That makes a fraction. The second one, if you ever need to use it, makes a mixed number. But we need a fraction, so we're going to hit 1. And look at that, it makes a little fraction for me. How awesome is that? 4, and then I arrow down to 5. To get out from underneath here, I have to hit the right arrow. Remember, anytime I do any input variable, I'm going to use the XTON button right there. 4/5 x, and it was -6. My second line is going to be 2x plus 6, and then I'm going to, again, go into the table. I thought the answer was -10, so I'm going to scroll to -10. There it is. And at -10, I see -14, -14. And that means my y1 and y2 are equal. That's how I know I did it right. And so now I can say that I have my final answer. Last example I'm going to do, I'm not going to solve it all the way, but I am going to at least start it out with you because I want to show you the same strategy except with decimals. So I have 0.6p minus 8.48, that's a decimal, equals 0.42p plus 3.4. Okay? In this case, I don't know what it is. Maybe I've got, some kind of magical decimal messing up skills, but I can mess this up. I will somehow manage to get this wrong if I leave it as decimals. Again, I feel like in general, I, and really a lot of other people I see, tend to do better when things are as whole numbers. So, these are decimals. This is 6/10. This is 48 hundredths, 42 hundredths, and 4 tenths. So since my biggest value is the hundredths space, I'm going to multiply everything by 100, which will get rid of these decimals entirely. So 100 times 0.6 is 60p. 8.48 times 100 is -848. 100 times 0.42 is 42p. 100 times 3.4 is positive 340. Change my mind, I'm going to solve this one. Okay, again, now it's pretty numbers. We're going to solve it just the same way as we would. Okay, add 848, and only because I've done this 750 times today do I know that that is 1188. I'm going to subtract 42p from both sides, zero that out, and I've got 18p equals 1188. Divide by 18. I am not a math whiz. Again, I've done this 1,200 times. P is 66. Now, the reason why I wanted to show you this is because when I go into my calculator, there's another trick that I showed you today that I want to remind you of. 0.6x minus 8.48, arrow down, and I have 0.42x plus 3.4. When I look at the table, I am all the way at negative 10, and my answer is 66. So I got to scroll all the way to 66. I'm far too lazy to do that. So what I'm going to do is I'm going to go into the table settings. The table settings are above the window settings. So I'm going to do second window, and it has table start. Well, I want my table to start at 66 so I don't have to scroll. Now when I go back into my table, take a look at that. 66 is right there. So, and I can see that my answer is right when x is 66, y1 is 31.12, and y2 is 31.12, and that means I did my work correctly.